A new way to capture CO2 from factories or the atmosphere has been developed by researchers in the Oak Ridge National Laboratory, located in the United States of America. The new technology uses a different molecule to soak up the CO2, and it's 24% more energy efficient than the existing technologies. On top of it, the molecules can be reused up to 100 times, meaning even more savings. This improvement on technology may prove a very big step towards large-scale adoption of carbon capture, which could help slow down the effects of climate change. I'm Mariana Campos, and I've been chatting to Dr. David Fairen Jimenez from the University of Cambridge. David comments on the new research from the Oak Ridge Lab.
Carbon capture is the process where we continue using fossil fuels, but instead of releasing the CO2 we produce, this is the carbon, to the atmosphere, we try to concentrate it in a material in order to be able to avoid this pollution.
Why is it important to capture carbon?
Because this is one of the major agents in global warming and climate change. Currently, there is nothing that is used on a large scale, but there is a lot of research in academia and in industry about trying to provide new solutions to be able to continue using fossil fuels, but to be able to avoid all the pollution.
Are there any problems with these techniques that are being researched?
So the main problem is the cost. Basically, we need to spend a lot of energy to capture this CO2, and also we need to find a solution about what to do with all the carbon that we are able to capture. All this is based on the economics, and basically it's too expensive right now.
So what's the new thing that the lab in Oak Ridge did?
This new idea is based on what is more or less used so far, but is a big improvement in terms of the efficiency of the systems, and therefore it should be cheaper and more economically viable.
How much better was it?
About 25% more efficiency or cheaper system.
What does this new technique do?
So it's basically having some kind of molecules which are able to react with the CO2 molecule, and therefore they are able to soak up all the CO2 and they are able to accumulate it. And also it's very easy to recycle this material, so you can just heat up a little bit and then it will release the pure CO2 already concentrated in a flow.
What do you do with that CO2?
So this is the second big question. There are different solutions about pumping back the CO2 into old natural gas reservoirs, for example, but still there are a lot of questions. There is a small amount that we can use for some applications because CO2 is also a useful molecule, but we produce a huge amount of CO2 and we cannot use all that.
There's a cost associated with carbon capture and storage, investing into infrastructure and spending a lot of energy to capture that carbon. Is it worthwhile?
It is very important because we are increasing the amount of CO2 that we have in the atmosphere, and this is linked to the climate change we observe. So obviously, it doesn't matter how expensive it is, it's something we will need to do at some point.
And what's next? Can this technology be upscaled?
I hope so. This has been tried on a lab scale, obviously. If this is economically viable, this is something that chemical engineers and process engineers will need to decide. What are we going to do with the CO2? That's the next step. Where are we going to store it, all this amount of CO2? There's a lot of questions that are still quite open. It is very important also to remember that all these technologies are little steps, but obviously it's going in the right direction in order to reduce the emissions of CO2 in the atmosphere.
That was Dr. David Fairen Jimenez commenting on a new piece of research from the Oak Ridge National Laboratory. This paper was recently published in the journal CHEM.